the information I'll be sharing is based on my personal experience as 10 years as a mechanical engineer on the field, and also, of course, a lot of the research that I've done myself. With all that being said, let's jump right into it. And what is mechanical engineering? Let's set a foundation that's going to get us started here on a good path. And if you didn't know this, mechanical engineering is one of the most versatile and diverse engineering fields because it touches on different areas such as aerodynamics, electrical circuits, civil engineering, and at times even chemical engineering, as we will be showing a little later when we go over the coursework and degree path. Now, mechanical engineers do a lot of research. They do a lot of design, development, building, also testing of mechanical systems and components, but also what mechanical engineers do, also we focus on maintaining. When I first started my personal journey as a mechanical engineer, I was working in the naval industry and we were providing maintenance for the ships that were out at sea. We were doing maintenance on compressors, gas turbines, diesel engines, and things like that. That's one of the things that I think people need to know, because many times when you hear engineering, you only focus on the innovation, you only focus on the building of things, but you rarely think of the maintenance side, which, to be honest, can also be as exciting because you're looking for improvements, you're looking to be more efficient with the equipment. So we'll get a little bit more into this as we go through this video. Now, when it comes to the mechanical engineering degree path, these are going to be some general classes. I know that sometimes there are some schools that give you a few modifications to your engineering degree path, but generally speaking, the first one that we're going to be covering is, of course, math. Math is going to be one of the foundation and core courses for engineering in general, not just mechanical engineering. And you're going to be taking for math all the calculus classes. You're going to be taking calculus 1, 2, 3, differential equations, and some people take even math classes beyond that. Now, another core class for mechanical engineers is vector mechanics, and here we're talking about statics and dynamics. And I do remember when I first took dynamics, it was a nightmare. It was a very difficult class, but one of the things that I want to share here with you is whenever you are taking these hardcore classes for engineering in general, don't be intimidated by their name. I know that it's very difficult to not look ahead to see what's coming up, but if you just take one step at a time, by the time you take these classes, you will be ready to tackle the challenge that's in front of you. So focus on what's in front of you at the moment and don't focus too much on the crazy name for some of these classes. Now, other core classes for mechanical engineers involve material strength, material science, also, which is a very chemistry-based class. Material science for me also was very difficult. And of course, the more specific engineering classes such as thermodynamics, heat transfer, material processing. Also, you're going to be dealing with a lot of laboratories, labs, where you'll be doing hands-on work, you'll be doing technical reports, you're going to learn how to write and also how to give presentations. Also, of course, fluid mechanics, another difficult class that, depending on the professor, this can be a little more bearable than other classes. So the point here is so far that even though these classes are core for mechanical engineering and they can be difficult, make sure that you, again, take it one step at a time. Try to get a good professor. I know that it's difficult. And also work with your teammates. And when you work with a team, when you work with your classmates, things are going to become much more bearable. Now, something that I want to get into a little bit here, I know that we're going to get into this a little deeper as we go through this video, but programming is another class that a lot of people get freaked out a little bit by this, and they think, oh, I hate programming, I don't want to do any programming, I hate MATLAB, I hate Java. Personally, in my journey, I learned Java, and that was my credit for my programming class. But there are plenty of other students who decide to take MATLAB, which is a really good one. So far, I just want to mention that we're going to be talking on programming languages a little later once we go through that section. So feel free to skip ahead. But I just want to mention and let you know right off the bat that although programming is useful for mechanical engineers, and I think that we should have an idea on how to program, what programming entails. Don't be discouraged if you're someone that doesn't like programming. If you can get by, if you can get through your programming classes or class in mechanical engineering school, you don't have to see programming again once you join industry. There are plenty of jobs out there that don't require programming. Well, you use a lot of Excel, like really basic stuff. So don't think that you're doomed if you don't like programming. Because personally, I hate programming, but I can't negate the fact that, of course, it's a very useful skill to have. So those are some of the core classes. Also, by the way, I was forgetting about physics. Physics, of course, is very physics heavy. Both 2 semesters of physics and also a little bit of electrical circuits, 2 semesters of electrical circuits as well. So those are the core classes for the mechanical engineering degree path, generally speaking. Now, if you want to know exactly how long it takes, if you're someone that, starts thinking, hey, Alex, how long is a mechanical engineering degree going to take me? In the United States, generally speaking, it's going to take you between 4 and 4.5 years. I want to say that that's average. Some people take 5, some people take 6, even up to 7. I've heard of people taking even 10 years. But the bottom line here is going to be that don't be discouraged by the length of time it takes you to complete your degree. In the long run, no one is really going to care how long it took you, just as long as you're learning constantly throughout the process and you're exposing yourself to more education and you're leveling up your knowledge. If you are able to show that and show companies that, hey, you are improving, even though it's taking you a little longer, you'll be all right. You'll be set. So don't let that discourage you from majoring in mechanical engineering, because of course, not everyone has the same path along. Some people are working while they go to school. Others, they have emergencies. They have to take a little longer. So of course, life is not perfect. And this is just an average guidelines for 4.5 years. Now, let's talk about master's degrees when it comes to the mechanical engineering degree. And you might be thinking, okay, if I get my mechanical engineering degree, is a master's useful? Will I need a master's degree in order to get a job or in order to succeed as an engineer? And here I'm going to give you a very broad overview of the master's degree, because the master's degree is one of those things that there's a ton of parameters that you need to take into account, such as time, whether you have the funding, the money, of course, also whether or not you want to commit to a certain field for mechanical engineering. So generally speaking, based on what I've seen, if you want to move up the ladder, or the corporate ladder that is, or you want to be an expert in a certain field as a mechanical engineer, then yes, a master's degree in mechanical engineering is going to help you. Now, here's the caveat though. If you want to just move up the ladder into management and you want to be a director or something of that sort, look into also having a master's in management, or not also, but choosing to not do a master's of science, but choosing to do a master's in management, getting an MBA or things like that. Because many times companies just want you to have a master's degree that you can just check the box with, saying that you have a master's, but they don't require you to have a master's of science. Keep that in mind. You don't have to have a master's of science in order to be eligible for high-ranking positions in a company. And the reason I'm saying this is because if you can get an easier master's degree, why would you put yourself to this hard work of getting a master's of science if you're not going to end up using? Many times people just want to check the box and say, got a master's? Okay, cool. Move on. They don't care what kind of master's you have. Unless, of course, you are required to be an expert on a lead in a certain study or research. Now, on the flip side, if you just want to make a decent living for yourself and your family, and you just want to go out and move up as far as you can, you don't have to have a master's degree. Personally, I don't have a master's degree. Right now, I'm doing very well for myself. I am financially stable. I'm not living paycheck to paycheck. And it also depends, keep in mind that it's not really about how much money you end up making after you cover your basic needs of food, shelter, transportation. It's really about how you manage your money. So keep that in mind as we go through this video. So if you just want to make a decent living for yourself, then I personally think that you don't have to have a master's. I'm just going to leave it there because we can go into this rabbit hole of talking about a master's for a whole nother video. And if you want me to make a detailed video about master's degrees, then of course you can let me know in the comments below. Now, the next thing we're going to talk about here is the school name. Does the type of a school that you go to, that you attend for mechanical engineering matter? And I'm going to be blunt here. I'm going to be very honest. And I'm going to tell you that in the beginning stages, your school name does matter. Generally speaking, there are going to be some people out there who are going to say, well, I didn't go to a quote unquote brand name school or a top school, and I'm working as an engineer and sending stuff to Mars and I'm doing all this crazy stuff. I get it. But here's the main benefits of attending a top school or a recognized, well-known name. Number one, the network, the people that you surround yourself with. If you go to a top school, then the kids that you're going to be attending school with, they will be more competitive. They will be just as smart, if not smarter than you are. And so they're going to push each other, and there's going to be a lot of motivation. Now, in smaller schools where getting in is not as difficult and it's not as competitive and it's not as selective, then the diversity of the intellectual diversity will be wider. How about that? You like the way I put that? Now, the other thing is companies. Companies go recruit at big name schools. I mean, think about it for yourself. If you have a company and you know that there's school A that you can go recruit at MIT, or would you rather go recruit at a school in the middle of nowhere that no one has heard of and no one knows about, and also that doesn't really have a good reputation? As a good company that wants to hire top talent, most likely you want to go to MIT and hire people from that company. Now, I have read studies in the past that the name of the school also influences your starting salary, which in the long run also influences how much money you end up making. So yes, the school name does matter. Now, the one caveat I want to share here with you though is if you do attend a small school or that not many people have heard of, but they do, some of those schools actually do also have really good engineering programs. They're just not well known yet. And the reason for that is obviously because they have smaller classrooms. There's more attention to detail to the students, more help. So don't get discouraged. Personally, I work with plenty of people who go from a variety of different schools that are in the same office. I work with people from MIT. I work with people from Virginia Tech, from UVA, and other tiny schools. Like my boss, my program manager, he went to a little tiny school that I've never even heard of. So don't think that just because you are not attending a top school that you are doomed. And if you are attending a top school, it doesn't mean that you have it all figured out and that you're going to be able to succeed anyways. There is a slight advantage, yes, but it doesn't mean that you're doomed if you attend a small school. You just have to work a little harder in getting your experience, your first internship, your co-op. And once you do that, once you're able to get that experience, then your experience is going to end up mattering more. And also, if you're really good at networking, of course, that also does help a lot. After you get experience, then that's what counts. And so it is what it is. It's one of those things that you just have to learn how to deal with. So that's with respect to whether or not the school name matters. So now, the next thing that we are going to be talking about here is salary. Now, before I go deep into this, the first thing I want to say here is that the salary, it's going to be heavily dependent on your location, your industry, and as you gain experience, of course, it will depend on the type of experience that you bring to the table. Maybe you become an expert in a specific niche, in a specific area. Of course, also the other type of experiences, the years of experience that you bring into a certain field. But generally speaking, we're going to be talking about entry-level career and mid-career. Now, for mechanical engineers, the entry-level salary, the median salary, according to Indeed, Salary.com, and even the American Society of Mechanical Engineers, depending on the source that you look at, it's going to range between $60,000 and $70,000 per year, median. Personally, when I started my journey, I started making $54,000 a year, which if you adjust for inflation to nowadays, maybe ends up being about $60,000. Now, when it comes to higher education, if you're thinking, okay, that's with entry level with a bachelor's degree. Now, what about a PhD and a master's? Do you actually make more money with a master's degree or a PhD? And the short answer to that, according to the American Society of Mechanical Engineers, is yes. you have the potential to earn more money with a PhD and a master's degree. I've seen sources that say that you can start with approximately 10 to 20% higher than somebody that has a bachelor's of science in mechanical engineering. So that's basically, I mean, it's kind of like what you expect, right? Like the more of an expert you are in one field, you have the potential to earn a little bit more money. And not to mention that a lot of companies count a master's degree or a PhD as experience already. Like, for example, if you need 5 years of experience for a position, they tell you you need 5 years of experience with a bachelor's or 3 years with a master's degree. So it just really depends where you end up. So these are just some general guidelines. Now, when it comes to mid-career, and by mid-career, I am talking about people that have been in industry between 10 and 20 years, maybe a little bit more sometimes. It's crazy. I've been in industry already 10 years. That's a lot of time. And before I know it, I'll be graduating. So if you do have a master's degree or a PhD, generally speaking, you do have the potential to make more money in the long run. With a PhD, the median salary, according to the American Society of Mechanical Engineers, they did a survey a couple of years ago. The median they found is $155,000. If you have a master's degree, the median was $125,000. If you have a bachelor's degree, the median was $118,000. So as you can see, the lower the degree, the less money median you end up making according to ASME. Now, here's one wild card that I want to throw at you, and that is the professional engineering license that you can simply attain, not simply, but you can get with a bachelor's of science in engineering. We're going to touch into this a little later, but since we're talking about salary, I just want to throw out there that a PE license does help you make more money overall. And the ASME, the American Society of Mechanical Engineers, says that the median salary for professional engineers is $133,000. So about $15,000 more than somebody with a bachelor's. So overall, I do want to mention that an engineering salary is not going to make you rich. It's not going to it's not going to help you drive Lamborghinis and Bugattis on the weekends. You're not going to be able to get a Malibu house or a house in Malibu in California with an engineering salary, at least with a mechanical engineering salary that I'm talking about here. So, but it really depends on what you do with your money. Again, it's not really about how much money you make after you cover your basic expenses. It's really about how you manage the money that you make, because you can be making $300, $400, $1 million, but if you are always spending more than what you make, then of course things are not going to end up well. Okay, now since we are in the topic of money, let's go over some of the top paying industries for mechanical engineers per multiple sources. And the top ranking one is oil and gas. The oil and gas industry is $124,000 per year. And if you think about it, it makes sense because engineers in that industry, they get out there dealing with the weather, heavy machinery, there's a lot of things going on. And so it makes sense why they pay this much. Now, the other top paying industry for mechanical engineering is aeronautics. The average there is $109,000 median. Now, the third top paying industry for mechanical engineers is nanotechnology at $100,000 per year. Then we have robotics and automation. This one goes below the six figures at $92,000 per year median. And then the last one that I just wanted to throw in here, because you can't talk about mechanical engineering if you're not gonna talk about automotive and the automotive industry, automotive engineers. So for automotive engineers as an industry, out of the five that I'm ranking here is the lowest at an $83,000 median salary. If I missed any, and if you think there's one out there that I'm missing, let me know in the comments. I would love to know. Now, when it comes to branches for mechanical engineering is so broad that you can literally spend maybe a couple of hours listing all the branches and different threads that you can pull from mechanical engineering overall. But here I'm going to give you a few that I'm going to give you. They're going to be very general, but they're going to let you know some of the core branches for mechanical engineering. And I'm going to start with acoustical engineering, which deals with control of vibration and to reduce unwanted noise. You're going to be finding a lot of these acoustics engineers when you deal with components or systems that need to be quiet, that don't need to make a lot of noise. Think of being stealth. So I'm just going to leave it there. Now, the second branch that I'm going to list here is the industrial manufacturing engineering, which deals with optimizing manufacturing techniques, developing processes, as well as machine tools and equipment for manufacturing goods, and also bringing ideas into products. So it's a very general overview of a mechanical engineering field, but you're going to find a lot of engineers there too, mechanical engineers. Now, the third branch of mechanical engineering, we're talking about thermal engineering, and we're talking about creating and maintaining comfortable and safe environments through the control of heating and cooling systems. One of the most famous ones out there, it's the heating, ventilation, and air conditioning industry for commercial buildings or houses. And the other one that I'm going to be referring to here is the vehicle engineering. And I was talking about automotive engineering a little earlier. But yeah, so also that's another branch of mechanical engineering when it comes to the design and manufacture of all things vehicles, including, and this brings me to my fifth branch here, aerospace, ocean engineering, dealing with engineering, maintaining, designing, development, building aircraft, spacecraft, watercraft. Now, throughout all of these branches of mechanical engineering, you may be doing research and development, you may be doing design, testing, maintenance, you may be doing project management later down the road. So again, these are just some general guidelines. And with mechanical engineering, there's a ton of branches that we can go over for hours. And if any of these is something that you enjoy, hey, I would love to know. Let me know in the comments which one is the most appealing to you. Now, let's switch gears here a little bit and let's talk about the work environment for mechanical engineers, because the way I see it, there are two, or maybe you can even say three types of environments for mechanical engineers. And the first one, it's going to be the industrial side, where you're working outside, whether you are dealing with the weather, or maybe sometimes you are in a warehouse you're in a facility where you're dealing with a lot of testing, a lot of machinery. You're working back and forth with folks in the office. Sometimes you may need to travel to where things are. Like, for example, when I was working with ships, as I mentioned a little earlier, some engineers would have to travel either overseas or across the country to go and check the ships themselves to make sure equipment installation would be seamless and the drawings that we were developing as engineers actually portrayed what was actually happening in real life. So these are just some things that you need to take into account. So that's the industrial side. Now, majority of mechanical engineers, as far as I've seen and as far as the research and my personal experience, is going to be in the office. If you're doing design, if you're doing approvals, you're going to be doing paperwork, maybe some programming, simulations, drafting. And I do want to mention that if you are someone that wants to learn as fast as possible, if you are someone that you want to get out and be an expert in your craft, whether if it's something that you want to learn hands-on, I do encourage you to go to the field and get out there, because that's where you learn the most. Now, the third work environment that I'll be sharing here, it's kind of like a hybrid between an office that is in an industrial site, and I've worked in that type of environment in the past. It's actually kind of cool because you're working in an office and then you are checking your drawings, you're building something, you're writing up your contract, and then you immediately leave the office and go and talk to the people that are going to be doing the actual work, the technicians, the welders, the machinists. Personally, I think a hybrid, the best environment, but I know that, of course, that's not going to be feasible and viable for many engineers. Also, your work environment is going to be depending on the size of your organization. If you work for a very large organization, engineering firm, you may be bound to do just one type of duty. You may be only doing design and drafting, and you may pass those drawings on to the next test engineer or the field engineer, or those test procedures to somebody else so that they can do the testing. But if you work in a smaller organization, you may be wearing multiple hats. And what that means is you may be doing your drawings and building something in your computer, and then you print it out or you start grabbing those instructions, and then you immediately go and test it yourself with your team. So it's actually kind of cool if you're working in a smaller organization that allows you to do this, because you are literally overseeing the whole process of an idea, a scratch, and actually making it work. Especially if you're doing research and development, I want to say that's actually very, very fulfilling. And if you do happen to run into a research and development position, I want to tell you that's probably one of the best, if not the best position to be as an engineer, because you are literally testing, you're innovating, you're improving technology, you are making things happen almost from scratch depending on what you're working on. You are overseeing the whole process and you're making it come alive. I know that I've done this personally when I was much younger. About a couple of years ago, I left research and development, and now I'm thinking, man, I shouldn't have left. That was actually a really sweet gig. But at the time, I was ready to move on to another job. But that's enough of me. Let's keep focusing here on the mechanical engineering career. When it comes to the paths beyond graduation, if you're wondering, Alex, okay, I'm sold, bro. I want to go and want to pursue mechanical engineering. What awaits me? What is there for me in store after graduation? The first path that I noticed, and this is an observation, is the office work where you stay technical as an engineer, as a mechanical engineer, or of course also in the field, right? But you stay as an engineer overall. And I've met engineers who go 10, 20, 30 years, 40 years doing technical work. And that's because they truly enjoy doing the calculations, doing the problem solving, and doing the modeling and doing all. Those are the true, I want to say the true people that just really love what they do. And they don't want to move up, because when you move up, you start dealing with more politics, you start dealing with more administrative stuff, more decision making, and less technical work as an engineer. So that's one path that you can follow after you go beyond graduation. The second one, needless to say, is going up the corporate ladder. And when you go up the corporate ladder, you generally have two options. You can become a leader in a technical field. You can become a principal engineer or a chief engineer, senior engineer. Also, there's a very technical roles where you have a higher pay, but you're still a leader. You may be a mentor, but it's still technical. You're also making decisions on the technical side. Now, you could leave the technical world if you're someone that doesn't really like that much, which is, I'm kind of like that. I don't really want to do too much technical work. Then you can become a manager. You can become an engineering manager, an engineering director, program manager, project manager. Those positions are a little bit more administrative, more management, more leadership. And so don't think that you're just bound to have one type of work and it's only you doing calculations forever. So just keep that in mind. And now the third option as a path beyond graduation, when you join industry, you can also open your own business after you are done, or maybe you get into an industry and you get a lot of insight and you start realizing, my industry needs this, needs a type of service. Maybe your industry needs a type of product, or maybe something could be streamlined. Maybe you can provide something faster, a part, or maybe a process that your company that you're working for needs at the time, and you're seeing, you start analyzing, you start paying attention. So a lot of people go do this and also open their consulting companies. They have their professional engineering license and they can go ahead and do that. Now, last but not least, when it comes to paths beyond graduation, then you can also open a YouTube channel or social media and start sharing your ideas, sharing your opinions, your thoughts, your findings, etc. Now, not that I know that. Now, the next thing that we're going to be talking about is a little bit of job metrics. And by job metrics, I mean the satisfaction for mechanical engineers overall. You might be wondering, hey, is it really a good career? Well, our friends at PayScale, they surveyed about 4,200 people, and the result was actually a little bit surprising for me. Mechanical engineer got a 3.7 out of 5 job satisfaction, which actually makes it highly satisfied. And part of that, I want to say that generally speaking, there is a good work-life balance. I know some people are going to say, I work 12 hours, 14 hours, 16 hours. I know that I've been there. But in the long run, I want to say that there's an overall good work-life balance. And also, if you're taking something from scratch and you're bringing it all the way to creation and production, then I want to say there's also fulfilling and satisfying. Now, the other thing when it comes to job metrics I want to focus on here is the job growth projection through 2030, according to the Bureau of Labor Statistics in the United States, and that is 7%, which is about as fast as average. And the last one, when it comes to job metrics, there is this website called Will Robots Take My Job? And it gives you a general assessment on whether or not your job can be automated. And for mechanical engineers, there's a very low risk of automation. And I want to say that this is mainly because of the originality, persuasion, explanation. Like, it's not a field that is repetitive, takes a lot of common sense, physics knowledge, and for now at least, that's difficult for robots to start simulating and to perform hassle-free. Who knows what will happen in the future. So the job satisfaction is good. The job projection is average, about even slightly above average, about 7%. Average is about 4 to 5%. And now it's not a career that right now is projected to be automated. So all these things, these metrics make mechanical engineering a solid pick. Now, let's keep going here a little bit deeper into the licenses and certifications for mechanical engineers, because this is a very, very common question on, hey, what kind of licenses or certifications do I need? Or do I even need anything as a mechanical engineer? And the most common ones that I'm going to talk about here is the engineering in training, or the fundamentals of engineering exam, which is something that I personally took in my senior year as an engineering student. I passed it. I have a video that you can watch on how you can study for it, and I'll give you my insights. But the main purpose of this EIT, or this certification, is to get you ready so that you can take the professional engineering license. Now, I have heard of some companies that want you to take the engineering in training because it does help you get a job. And it basically tells the world that you know the basics of engineering, because this test, the fundamentals of engineering test, it's about 6-hour test. When I took it, it was 8 hours, but now it's 6 hours. And it asks you really general and basic questions throughout of the 4 years that you just spent in college. So I suggest every mechanical engineer to just get it out of the way. And the worst case scenario, worst thing that happens is you don't use it. Now, let's talk about the professional engineering license a little bit, because I did touch on this a little earlier. And the PE license does help you make more money in the long run. It helps you move up the ladder. And you're going to need a professional engineering license if you're someone that is going to deal with public safety, if you're going to be dealing with the government, sealing drawings, signing off on designs. So that's when the professional engineering license really comes handy. And it also gives you a little bit more respect amongst other engineers who don't have the license. And the reason I'm saying that is because it is straight up tells people that you know what you're talking about, that you have a basic or an advanced level of understanding in whatever your field is as a mechanical engineer. So it does have some weight on your credentials as a mechanical engineer. Now, a wild card that I want to throw here is the PMP, and that is the Project Management Professional certification. If you want to become a program manager or a project manager, some companies may ask you to get this type of license, for which they'll pay. You don't have to have it to become a project manager, but if you want to go that route, it's something that you can look into, and you can take the the Project Management Professional, the PMP. It does help if you want to get a job as a project manager. Now, other certifications that are going to be very industry dependent. I'm talking about computer-aided design and digital manufacturing, assistive design certificate, digital manufacturing, and design technology certification. The bottom line here is when it comes to certifications overall and licenses, before you get it, think about how it would help you and why you really need it. Don't just invest all your time, don't just invest all your money into something that's not going to give you a return on your investment. So that's definitely something to keep in mind, and something that I'll learn early on in my career. So basically, don't waste your time and money on things that are not going to give you a return. Now, let's talk about the skills that you need to excel as a mechanical engineer. What are the basic skills? And here I actually broke this down into 2 categories. And the first one that I'm going to be going over is the technical skills. Here, on the technical skills, we're going to be talking about modeling. Whenever you are a mechanical engineer, you have a basic understanding of modeling, whether computer-aided design, and some of the software that is widely used that is good to know is Autodesk Moldflow, common for mechanical engineers, also SolidWorks, CATIA, Inventor. I've met mechanical engineers myself that have worked with CATIA a lot, very heavily, and this is going to depend on the company. So it's not something that you can learn and then, the same thing is going to be used once you join any company. But the one thing that we all can agree on is once you learn one of these languages or one of these software, once you learn how to use one of them, than learning another one that is similar, because they're all somewhat similar because they do the same thing. So they're going to be asking for the same parameters. You're going to be drafting the same things with the same shapes. And so there's a lot of common things that are going to be taking place between all these software. So if you know one, then most likely you're going to be okay learning another one. It's going to be you're going to learn it a little faster. So that's with respect to modeling. Those 4 software are pretty useful. Now, when it comes to programming, this can be a little controversial one because some people are going to say, oh, I hate Python, or I hate MATLAB, I hate Java. So some mechanical engineers really don't like any programming, like I'm in that case, but we can't negate the fact that programming is definitely a solid skill to learn, especially nowadays, right? So it's really going to depend on what you want, where you want to work, and the type of field that you want to get into. So what I would do before you learn any of these software or any of these programming languages, I would definitely look into the type of position that you want as a mechanical engineering industry. Like look at the job description and see what kind of expertise you need when it comes to modeling software or programming languages. But generally speaking, when it comes to programming, a very, very common one is MATLAB for prototyping analytical models. And this one is easier to use because it has a lot of built-in commands, which for mechanical engineering purposes, really that's the job. Another one that is commonly used for mechanical engineers is Python. This is less easy to learn. It's a little bit more difficult, but it's open source and it's free, something that you can use. You don't have to have a license for it, and so you can kind of practice on your own. Unlike MATLAB, you have to have a license through your school usually. Now, there are other languages out there that are useful if you want to get into software or information technology, such as the case of C, C++, and Java. Now we're getting a little bit older here. We're getting really down to the core of programming languages. These are just some general guidelines for programming languages: MATLAB, Python. Those 2 are the most common ones. And if you really want to learn one and you don't have the money, you don't have a license, then I want to say that Python is probably the best one to start getting your feet wet and get started. I do want to mention though, just like the previous part when I mentioned that once you learn one type of software, it will be easier to learn another one. The same thing with programming languages. Like I personally learned Java, and just because I learned Java when I was learning in my journey, it's easier for me to understand. I know how the code works in the sense of what is needed, like what I need to do, like how commands work and things like that. So it's easier to learn other languages. So if you go to a company that requires you to use a random language, it's probably going to be a little easier for you to learn if you already have a basic understanding of how coding works. Now, other technical skills that basic knowledge, basic technical skills that you'll need as a mechanical engineer. Math, of course. Personally, I've done very little math, but I have worked with engineers that do use math, even up to differential equations and beyond, in order to model system behaviors. So physics, thermodynamics, fluid mechanics, mechanical design, vibration, system dynamics is really going to depend on the type of industry and the type of work that you end up doing. Also, what really does help as well when it comes to technical skills, I want to mention that it's the hands-on work. If you know how to handle machinery, equipment, compressors for testing, so if you know and understand how things work and how they're put together in real life, then I want to say that's something that can set you apart in an interview or for a certain job that you are applying to. Now, that's basically with respect to technical skills that are basic for mechanical engineers. And then you have your soft skills. And any mechanical engineer or anyone that is in corporate America, anyone really is going to tell you that your soft skills are really what are going to help you set you apart. And the first one is, of course, communication, which is going to help you sell your ideas, selling yourself. Presentation skills, depending on who you're talking to, you have to adapt your language and the words that you use, the concepts that you use. It's not the same when you talk to an engineer as it is to talking to a business person or your program manager. So you got to change your language. Also, depending on the hierarchy of who you're talking to. Also, a good personality is going to take you a long way. And you don't have to be best friends with everyone, but if you're a professional, there's a Forbes article a little while ago that I read that your success depends a lot on your likability. And personally, I've seen this plenty of times where I've seen people that are highly qualified for a job, they don't end up getting a job. It's actually more about whether or not the people at the top actually like you. So just one of those things that you have to learn how to deal with. And hey, you gotta do what you gotta do. Now, with respect to other skills, we're talking about problem solving, creativity, working as a team, vision. And I do want to point out here as well that don't get caught up in these skills and think that you have to learn, you have to know, you have to be a pro, you have to be really an expert in all of these. These are things that you develop along the way. And as you develop as an engineer in your journey, that you're going to start being more proactive. You're going to learn to work as a team more. You're going to be developing vision, and you're going to learn how to problem solve a little better because of your experience and the insight that you're gaining along your journey. So just be willing to learn, be open, be like a sponge in the beginning, learn from other older engineers, ask questions, and you're going to be just fine. A couple of last things that I do want to mention here is let's be a little less biased. Let's talk about advantages and disadvantages when it comes to the mechanical engineering career. And let's start with the cons. How about that? And one of the cons of mechanical engineering is that it's broad. It's like a jack of all trades, master of none type thing, which can affect your pay. But the one thing that mechanical engineers do have going for us, the one thing that we do have going for us is that once we are exposed to the field with enough training and guidance, we can technically start focusing on anything that we need to learn. For example, when I was about 3 years in the field, I was leading a project for electrical engineering. I was dealing with electrical switchboards, and I was working with a bunch of other electrical engineers, and I was learning a lot from them. So technically, if I wanted to dig deep into electrical engineering components, and I was learning a lot about it, power generation, power distribution, switchboards, breakers, bus bars, and all those things. And if I wanted to go down that route, then with my mechanical engineering background, I would have been able to do that. So even though it's a con, it's also something that allows you to be versatile and move around as a mechanical engineer. Also, another con for mechanical engineers is that the hours may be long depending on where you end up in industry. You may be in a desk for God knows how long or forever, who knows. And the beginning stages can be a little difficult because you're not making life-changing decisions. You're not really in charge of very large projects. I mean, think about like a company. If you were a company, would you give a high visibility project, very important project, to the junior engineer that is just getting out of college and entering your company, or would you give it to the senior engineer? So don't get discouraged. The beginning stages of your engineering journey can be a little slow, but then over time it's going to pick up and you're going to get more responsibilities. Now, when it comes to pros of mechanical engineering, an advantage is that a Bachelor of Science can take you far, and it has a lot of great pay potential. And also, as I mentioned a little earlier, it's broad, it's general, which allows you to select the path that you want. You can get into aerodynamics, structural analysis, electrical circuits, and even programming if that's something that you really want to get into. And also, it can be very hands-on depending on the industry and job that you get into. So that's basically what we have for advantages and disadvantages / cons, pros and cons for mechanical engineering. If you can think of any, let me know in the comments. I would love to know. Now, some final thoughts here. And really, is mechanical engineering a good path for you? Is there really a good field? Well, if you're someone who likes hands-on work, if you like to have a general knowledge of different engineering fields, if you enjoy physics, and you don't want to be pinned down to one specific niche in college, then it can be a great path and a great field for you. And just keep in mind that even if it doesn't work out, you could still pivot to other areas. So don't think that just because you don't like your first job or the first industry that you get into, you'll be stuck forever. So I've met plenty of engineers who will leave the engineering industry, they start their businesses, but at least they already have the knowledge, they already know how to learn, they learn how to think, they're very analytical, they're very versatile. So those are the skills that really set you apart as a mechanical engineer. And things that are transferable to other industries, not just for the engineering industry. And that's one of the reasons why also engineers in general are highly sought after, I want to say, because we're very analytical, logical, data-driven. We can read graphs, we can make recommendations, project things. And so you're learning really good skills, so don't think that you'll be stuck with one field. Overall, I want to say that mechanical engineering is a great field, good job growth, job prospects for the future. It will not be, there's a low risk of it being automated, at least for the time being. There's lots of opportunities, and if you don't like what you get in the beginning, then you can always pivot and you're going to be pretty much set. Also, it gives you a very comfortable lifestyle that allows you to explore other interests at the same time that you are working in your journey. So if you want to escape the mechanical engineering world later down the road, then you can do that while you work your job, and your job can allow you to support any hobbies or invest in a startup or open your own business or whatever it is that you want to do really down the road. So always just keep in mind that your future depends on you. You create your future. So if you are someone that wants to know more about my personal journey as a mechanical engineer, if you want to know about my entry-level mechanical engineering experience, go watch this video right here where I tell you how I started, what I was focusing on, the type of work that I did, the salary that I was making, the work hours. So I'll see you on the other side. Like this video, subscribe to the channel, and I'll see you on the next one. Peace.